Welcome to Study Loop.
All right, hey guys, today we're doing problem 48 in chapter 5 of Chemistry Central Science. So we're looking at the decomposition of benzene C6H6 X2 gaseous acetylene C2H2. So we see this reaction up here. So C6H6 X gets converted to 3C2H2 with the change in enthalpy being a positive 630 kilojoules. So for the reverse reaction, the change in enthalpy for the reverse reaction is just the opposite of what we see for the forward reaction up here. So the reverse reaction change in enthalpy is going to be minus 630 kilojoules. Part B is we're going to be learning what is delta H for the formation of 1 mole of acetylene. So in the forward reaction, we're producing 3 moles of acetylene from our 1 mole of benzene. So this is a very simple way to go. We do 630 kilojoules divided by 3 moles of our acetylene, and this produces that's 210 kilojoules per mole. So 1 mole of our so the H for producing 1 mole of acetylene is a positive 210 kilojoules. So there's a general rule when it comes to thermodynamics about how to determine if a reaction is favorable. If delta H is negative, then your reaction is favorable. If delta H is positive, your reaction is unfavorable. Because when delta H is negative, that's an exothermic reaction, going from a high energy level to a low energy level. Well, if delta H is positive, that means you're going from a low energy level to a high energy level. So you have to input energy in your system to force there's an endothermic reaction in a general sense. And so the reverse reaction, the formation of benzene from acetylene, is more likely to be favored. So for part D, they want to know if gaseous benzene would be consumed more readily than and liquid benzene, and how would this affect the delta H? So I would expect the gaseous benzene to cause the delta H to decrease. It's because when you're doing this kind of reaction, you're not just converting benzene to acetylene, you are also producing a phase transition, going from liquid to gas. And to go from liquid to gas, you have to input energy in your system. You have to break those interactions from the molecules in the liquid state to be able to push your molecules to go to the gas state. So if we were using gaseous benzene instead of liquid benzene, that would cause the magnitude of our delta H to decrease because the reaction would require less energy and therefore be more favorable.